This conference will now be recorded.
All right, this is Math 211. This is extra examples from Appendix D on trig review, graphing some more of the just trig functions and their reciprocal functions. So we're looking at cosine x here, and remember that cosine x comes from all of the x values of the unit circle when we have a specific theta. So our function input value is the theta, and the output value is the x value that coordinates to on the unit circle. So when we plot this, we know cosine, but we've done it plenty of times. We know that at our key points, which I'm going to go ahead and list what those are, 3 pi over 2 and 2 pi. And then we have the negatives over here as well. Negative 2 pi. We know that it starts at 0, 1 up here at the beginning at the origin, and then it goes down to 0, then down to negative 1, back up to 0 at 3 pi over 2, and back up to 1. And remember, that pattern just can repeat over and over and over again. So we kind of sketch that in. Okay, so when we talk about secant, we're talking about, remember, the reciprocal of all the cosines. So if you think about it, remember, this is the point 0, 1. So when we look at that as an ordered pair, remember, we're going to be flipping the y value essentially, which is our ratio. So remember, we made a chart in class to help us see this. So remember, this is the point 0, 1. Pi over 2 was at 0. Pi is at negative 1. And 3 pi over 2 is at 0. And 2 pi is at 1. So when you flip these, this becomes still 1. This would be undefined. This would still be negative 1. This would be undefined. And this would be 1. Now, this is going to do exactly what we saw with cosecant. And remember, it was that there are undefined places, we know. So pi over 2 is definitely undefined for secant. And so is 3 pi over 2, which is right here. And that pattern is going to continue essentially this direction as well. So every time we go that 180 degrees, we get that asymptote. Now, just like with cosecant, we notice that the in-between parts are actually important because they tell you what's going on here. So remember that if you're at cosine of, let's say, pi over 3 and pi over 6, those are two easy ones to compare. So remember, the cosine value at pi over 6 is square root of 3 over 2. The cosine value at pi over 3 is 1/2. So when we flip that, that's a 2, and this one is a 2 square root of 3 over 3. So when we're plotting these, so let's go ahead and plot. So 0 is still at 1, but when we're at pi over 6, which is the one closer to 0, we're at 2 square root of 3 over 3. So if you don't know what that is, we could always use our calculator. Of course, you don't have a calculator on your test, but we're just analyzing this right now so you can see the pattern. And then we divide that by 3. It's a little bit bigger than once, 1.15. So notice that's going up. And then 2 is getting even bigger. So we're seeing that pattern we saw with cosecant, which is that this is headed towards infinity, and it's going to do the same thing on this side. Whereas when we get in the next group, we're at -1, and we're going to be heading down. So we're going to get these kind of alternating, almost parabola-like things. And that is just those reciprocals of those values. And that pattern repeats forever. So this is found just by taking each value of cosine and making a reciprocal to the actual ratio of the triangles. Because you have to remember, when we're doing functions that are trig functions, the x or input value is always the angle, and the output value is its ratio as a triangle, like sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. Okay, so for tangent and cotangent, those are slightly different because they come from the ratios of the unit circle of y over x for tangent. So let's just briefly draw out this so we can get a couple of our ordered pairs. So remember, this is 1, 0, and at 30 degrees, we know that our ordered pair is square root of 3 over 2 and 1/2. At 45 degrees, we get the ordered pair square root of 2 over 2 and square root of 2 over 2. And at at 60 degrees, we get 1/2 and then square root of 3 over 2. And then up here, we get 0, 1. Remember, that's just the first quadrant of the unit circle. So if we're doing the tangent function, remember at 0, we would be putting 0 over 1, so that's going to be 0. At pi over 6, we'd be putting 1/2 over square root of 3 over 2. Now the 2's are going to cancel out. If you think about like multiplying by the reciprocal, this ends up being 1 over the square root of 3. At pi over 4, you put the same thing over itself, so you get 1. At pi over 3, we get a square root of 3 over 2 over the 1/2, so that's just going to be square root of 3. And then at 1, 0, 1, we get that it's undefined because at pi over 2, you get 1 over 0, which is undefined. And we can continue on in this fashion. We could do some negative angles and see that it goes not uphill but downhill. So when we plot the first part of tangent, we see that this is 0, 0, pi over 6, 1 over square root of 3. It's kind of close to that. Then we get to 1 and then square root of 3. And then we have this asymptote. And what happens is that tangent is an odd function, so we end up getting kind of a mirror image on the other side, but it's heading towards negative infinity. And that's just because of the signs of the ratios. So then this pattern also repeats just like all of the other trig functions patterns. And I'm not going to draw all of these in, but you get the picture. So repeats all the way across. So then cotangent, let's analyze just really quickly what's happening there. So remember, cotangent is the reciprocal of this. So at 0, when you flip this y value, you get undefined because the 0 ends up on the bottom. And if we flip this at pi over 6, that would be square root of 3 over 1. Pi over 4 would still be 1. Pi over 3 would be 1 over the square root of 3. And here, if you flip this, it ends up being 1. Or excuse me, 0. Sorry, talking too fast. So that one ends up being 0. So now we're undefined here at the y-axis, and then the pattern has been shifted over. Now there is another change. Pi over 6 is square root of 3, which is about 1.7 something. So that's up. Then we come down to 1. Then we come down to 1 over square root of 3. Then we come down to 0. So notice now the pattern's not going uphill from left to right, but downhill. So the pattern has been essentially flipped. And we've shifted where those asymptotes are. And again, the pattern repeats over and over again. Now, when we talk about these asymptotes, remember we can talk about them as a pattern of repetition. These happened at the first time it happened was at pi over 2. So we would say that x cannot be pi over 2 plus any pi n, because remember this is 180 degrees between each of those. And this started at pi over 2 as well. So x cannot be pi over 2 plus any pi n where n is an integer. And here x cannot be 0 plus pi n. You don't always write the 0. Some people just say x cannot be pi n, but I like to have my initial asymptote that I started with. So, all right, the last example in this section that we did not do together was a graphing transformation problem. So we want to make sure we review that. So this is one of those that we would have done in a Math 137 class, and we're looking for a few different things. We want to know what was the, are there any vertical shifts to this function? Because that changes the baseline of how you graph it. What's the shape? Is it cosine or sine? Amplitude, minimum, maximum, period, phase shift, all of those things are important, and usually we want about 5 key points when we graph it. So the first thing you should note is whether or not there's a vertical shift. And that happens if something has been added or subtracted, either sometimes in front or at the end of the function, and there is nothing being added or subtracted outside of this cosine function. I know there's a minus in here, but that's part of the argument. So there is none. Next thing I'm going to write down is what is the amplitude. The amplitude is found by taking the absolute value of the number in front of cosine. So that's going to be 1/3. That means we are actually, we're being compressed because this is going to have a height that is less than our normal cosine function for each of those hills. And then we want to know what's the general shape of cosine, and that does matter if there's a negative in front because that reflects your graph. So as long as you don't have a negative in front, your graph is going to look like the normal cosine that we're used to seeing, where it has a baseline at 0 for us, and it starts up, then goes down, then goes back up. And then we want to know what the minimum and maximum would be, and the baseline. The baseline is 0 if we are not going to see any vertical shifts. If we have a vertical shift, that becomes our baseline. The min and max are the amplitude subtracted and added to the baseline. So the minimum here would be -1/3, and the maximum height we will achieve is +1/3. So if our baseline had been 1, it would have been subtract 1/3 from 1 and add 1/3 to 1. Our period, we have a formula for that. We put the 2 pi, which is the normal period of cosine, divided by the absolute value of the coefficient that is in front of your x inside your cosine function. So that's 2 pi over the absolute value of 4, which is just going to be pi over 2. So notice this period is shorter than our normal cosine function. We also want to know if we have a phase shift. That's kind of like when we talked about horizontal shifting in algebra class. Now, there's a formula for that too. It's -c/b, and c is this coefficient right here. But I like to actually do it by sticking it between that expression that's inside the cosine, the argument there. I like to stick it between the normal stretch of the cosine function, which is 0 to 2 pi. If you do this and you solve it, you're going to actually get the starting and ending points for your complete period. So that's kind of helpful sometimes. So I'm going to add pi over 2 to all 3 sides. So that would make this 4 pi over 2 plus pi over 2. So that's going to be 5 pi over 2. We'll divide everything by 4 because we need to get rid of that. So that's going to make all of those denominators 8. Now, so my phase shift is a positive pi over 8. That's the starting number there. So when I go to graph this, I like to put a little table of values here to help me out with 5 key points. I already know everything I need to know for those 5 key points. I just have to make sure I get the correct values for the top. And that's really easy as long as you know your starting and your ending. So 5 pi over 8 is the end of our first part of this before it repeats its pattern. The way you find these 3 missing parts for essentially your x's is that we use kind of a midpoint. So this should be exactly halfway because remember this has a nice symmetry to its shape in terms of everything's evenly spread out. So the way you find a midpoint is you add these 2 guys together and then you cut it in half. So if I add them together, I get 6 pi over 8, and then I cut that in half. So that makes that a 3 pi over 8. Then to get this middle right here, I add these 2 together, which is 4 pi over 8, and then we cut it in half. So that makes it 2 pi over 8, which is pi over 4. And for the last one, we add these 2 together, so that's 8 pi over 8. We cut it in half. That's 4 pi over 8, or pi over 2. So now you can see that we have all of our x values for our 5 key points. Now, to figure out what you're going to put down here, you're going to look at these, the min, the baseline, and the max. Since this cosine function has its normal shape, which is it's not been reflected, we're going to start with the max first. So that is 1/3. Then it goes to its baseline, which is 0. It goes to its minimum, which is -1/3. Goes back to its baseline, which is 0, and goes to its max again, which is 1/3. So I'm going to kind of zoom in a little bit, and we're just going to mark pi over 4 and pi over 2 because the 8s will be in between those. So pi over 8 is my starting point, and I'm at +1/3, which is about right here. Then at pi over 4, I'm at 0. At 3 pi over 8, which would be exactly halfway between these two, I'm at -1/3. At pi over 2, I'm at 0, and at 5 pi over 8, I'm at 1/3. So we would kind of sketch the graph based on what we've seen. And again, you don't have to draw me a ton of it, just enough to get the idea. Okay. All right, and that is the end of this video.